25. Write the system of equations associated with the argument matrix. Do not solve it. So this is the argument, and this is the result of the argument by using the RREF. And RREF is the best convenient way to solve for your system of equations. And you should know how to using the calculate by solving the RREF after you watch the 6.2, 6.3 study material. And you can use the 84 graphing calculate to solve for the system of equation. Okay. So when the result of your argument by using the RREF, it gives us this 1, 0, 0, 0, 1, 0, 0, 0, 1. We call this type of the matrix is identity. 1, 0, 0, 1, 0, 0, 0, 1. So your 1, they all have the diagonal arrangement. The diagonal line has all the 1. And then all the rest of all the remaining number, they are 0. So in that case, we call this as identity matrix. So when you have the identity matrix, the first column represents the x, second column represents the y, third column represents the z. Right? Each vertical column represents a single variable. And that's why we use this technique to solve for the system of the linear equations. So the result here gives us x, this is x, equal -8, y equal 3, and the z equal -3. So the result has been shown here. So we just go pick the -8, 3, and 3. So C is correct. 26. The reduced row echelon form of the argument matrix of a system of equations is given. Find the solution of the system. So you need to find the x, y, z, blah, blah. So when I look at the arrangement of this, when I look at the argument is the same thing like arrangement. Okay. So when I look at the result of this argument, here, the first column, I have the single 1 and the remaining number, they are 0. So that means your x equals 3. The second column here, or the second row, I should say the second row, right? Second row here only have the single 1 located on the second column. So this is represent the y is equal 8. Z is equal 6. Now, the fourth row here, I'm going to use the W to represent it, and it indicates W equals 6. The fifth row here, I'm going to let, for example, T. Okay, put a T here. But wait a minute, I don't have the 1 here. If you look at the first four, the first 4 row here, each of the row they have the single 1 to represent a single variable, but not the last row here. So although I have the variable t label on the top here, because there's no 1, the 1 is not here, so I cannot use the t to represent it. So it turns out only way I can express this arrangement of the last row, I only can write down the 0 equal 1. But 0 is not equal 1. This is not a true statement. So in that case, the solution of this argument is no solution. Although I have the x equals something, y equals something, z equals something, and w equals something, but the last row just kill everybody. Okay, so it turns out no solution. 27. This is the argument after using the RREF. So the result give us this kind of the arrangement. I have the 1 on the first column here, so I'm going to write down the x because of 1x plus 3w. I'm going to label the number 4 column, the fourth column here as a w. So x plus 3w is equal to 13. Y plus nothing, right? So just y is equal to -9. Z minus 2w. So z minus 2w is equal to 4. The last row here, everything on the left hand side, on the first 4 column, they are 0. So I have the 0 equal 0. This is true. Alright, so the first 3, since the last row is a true statement, that means, yes, there's a solution of the system of equation. However, we have the w here. W is unsolved the variable. So only way we can perform the solution would be x equal 13 minus 3w. Y is equal to -9, and the z is equal to w plus 4. And then the 0 is equal to 0. So the solution we have here would be 13 minus 3w. Y is equal to -9, and the z is equal to w plus 4. And 0 equals 0, I can let the w equal w, right? If I have the variable, this one, I put the t here, then I can rewrite into the t equal t. Because this is always true. Whatever number you put on the left hand side, your right hand side just copy down the same number. Okay, so that's why our solution set the x, y, z, x and z, they all rely on w. Okay, and since the w equal w, your x just has equal 13 minus 3w, and y is -9, z is equal to 2w plus 4. So you should go with the option A. Number 28 is this 3 system of linear equation. Now since the third equation gives us the z equal 3, we should be able to plug in the 3 back to the second equation to solve for the y. So 4y is equal to -4z, right? And z is 3. So 4y is equal to -12. That means y is equal to -3. Now since we solve for y, and then we can go back to solve for x. So x is equal -2y minus 2z and minus 4. So x has a particular number. X is equal 6 minus 4 is equal to -4. So we have the x equal -4, y equal -3, and the z is equal 3. So they all have the particular solution. So that means they are independent. They don't rely on each other. Like the question 27, x and z, they all rely on w. So this type of the equations we call the dependent equations. They all depend on the w. Number 27, they don't rely on each other. We can solve for x and y, z without borrowing any variable to solve for it. So they go with the independent. #29, we have to determine whether they are dependent or independent or inconsistent. So the easy way, I will say create a 3x4 matrix. So you write down the 1, -1, 4, 15. 2, 0, 1, 4, 1, 5, 1, 9. So you create a 3x4 matrix, right? Go to second, go to the added, go to second matrix, move to the added, and you create a 3x4 matrix. After that, you go back to the front page, click on second matrix one more time, and then you click on mass, and you go to the REF to pull out the matrix A. And once you go through those process, it will give you the matrix with 1, 0, 0, 1. 1, 0, 0, 0. 0, 1, 0, 1. And the 0, 0, 1, 4. So it will give you this kind of the output. So that indicate the solution set of here is x equals 0. Let me draw the number line here. X equals 0, y equal 1, and the z equal 4. So each of the variable has a particular solution, has a number. They don't rely on any variable here. So they are independent as well.